golly, I get what a lucky person I am. Must be my lucky day. Because of this plus sign, I get to do two problems, okay? So now you have two problems. And all you do really is you take the derivative of the left side, you take the derivative of the right side, and then just slap a plus sign in between, okay? So if I take a look at this one, do you see what rule you would use to take the derivative of this first problem? Product. So it'll be the derivative of the first times the second plus the derivative of the second. Well, let's think about this real quick, guys. The derivative of sine u is equal to, and you'll have to know this for your quiz in a few minutes, is equal to cosine u du dx, right? And this is just the derivative of 3x. This is your u. So everywhere there's a u, I'm going to put in 3x. And this really just says the derivative of 3x. So now that I just transfer this up here, the derivative of sine 3x is cosine 3x times 3. You guys see where I'm getting the 3? Because it's the derivative of 3x, and that's just 3. Okay? Hopefully I did that right. So derivative of the first times the second plus derivative of the second, oops, times the first. Okay. Question, can I multiply this 3x together with the 3 and the 5x? No, why not?
Because the 3x is part of the cosine.
Yes, because 3x belongs to the cosine. Yes, so make sure you understand. You can put these together. You can multiply these together, and I do want you to, but please don't pull the 3x from its mama bear cosine, okay? So you can put in 15x there. All right, and then all I do here is I carry down the plus sign, okay? And then I take the derivative of this right side. Suggestions on the right side. Would you do product rule? Would you do chain rule? I mean, what would you suggest here?
Chain rule.
Chain rule. When you say chain rule, I'm not really exactly sure what you're saying, but let me just think about this. This 5 here, if you did product rule, you would see the derivative of the first, but what's the derivative of 5? 0. So product rule would work. Everybody good with that? Okay, so don't, if you're like, gosh, I don't even know, all I see is product rule, it would work. Just make sure you're saying the derivative of 5 is 0, not 1. Okay, so many students say derivative of 5 is 1. It's not, it's 0. Okay, but instead of product rule, I'm thinking use the 5 as a scalar. Do you guys remember that? Pull the 5 out, take the derivative of secant 3x, and then multiply the 5 back. So I'm going to just leave the 5 here, and then I'm going to take the derivative of secant u. Well, what's the derivative of secant u? Do you remember? Secant u, tangent u, du dx. Okay, what's my u in this problem? 3x. So this will be 3x, this will be 3x, this will be 3x, and I'm taking the derivative of 3x. Then I just transfer this answer here right up here. So this is secant 3x, tangent 3x, and what's the derivative of 3x? 3. And are you guys good that that's really the same as just multiplying by 15 in the front? Okay, so question, can I take this 15 and pull it to the front over here? No, because these plus signs actually prevent that from happening. Is everybody good with that? So I'm pretty much stuck with this answer the way it is. Okay, any questions on this problem? All right, let's move on to the second warm-up. Okay, look at this problem. Do you guys actually see that this is 2 problems in one also? You get to do 2. Do you see it? I know, your heart's beating fast. Okay, that's a good signal. You get to do 2 problems. All right, so I'm going to first take the derivative of sine pi. 0. Okay, actually sine pi is actually equal to 0. You agree with that? But then the derivative of 0 is actually also 0. So this is 0, so nothing really happens there. If I take the derivative of the right side, do you see the chain rule happening here? Okay, and this is actually a 1 in front of here. So if I did the chain rule, it'd be negative 1 times 11, which is negative 11. Okay, keep the inside, leave it alone, and move the power down by 10. Right? I'm doing by 1. Sorry, I'm doing the chain rule here. Leave the inside alone. Okay, guys, I have so many students have trouble leaving the inside alone. Okay, when you leave it alone, then the chain part of it is you take the derivative of it. Do you guys see the chain? Like this is the chain. Like this is why they call it the chain rule. Does that make sense? There's a chain, there's a connection. Okay? So if this is I can't tell if you're being sarcastic or not. Okay, if this is 2x minus 3, what's the derivative of 2x minus 3? 2. All right, this is a great answer. It's just that I like you to multiply all the monomials or all the numbers together. So this is a better answer for me. Okay, any questions on this problem? Okay, go ahead and pass up your warm-ups, guys. And there are 2 more problems I want to talk to you guys about. One of these problems is on your test, okay? And I haven't decided which one yet, okay? But one of these is on your test. And so I want you to, I don't know if you put this in your notes or I don't know where you put stuff, but you need to be able to do these problems. So can you quickly look at number 4 up here? Quickly look at number 4 and just jot down your answer. Okay, so please jot down your answer. If I don't see you jotting down your answer, I'm going to call on you. So please jot down your answer for number 4. So did you decide that this is actually the definition of a derivative? Yes. Okay. So make sure that if you decide it's a derivative, please don't tell me it's the function. Because when you find a function, what do you have to do to it? Take the derivative. Okay, so let's look at this. What is the function that you pulled out of this? 2 sine x. You should have seen that, okay? But guys, that's not the answer. The answer is you want the derivative of this. Okay, so the derivative of this is 2 cosine x. But that's not the answer either, okay? Because actually, this x here was not x. What did they replace the x with? Do you see it? 3. Yeah, it's 3. It used to be an x, right? But they replaced it with a 3. So this x here is actually a 3. So what you want to do is after you find the function, after you take the derivative of the function, everywhere there's an x, put in a 3, and that should have been your final answer, okay? Did you get it right? And if you didn't, find the part that you got wrong, okay? And make sure you correct it. You can do it for the test. You guys good on this? Okay, let's try this one. Very similar question. Then I'm using a different definition for a derivative. See if you can do this one. Amy, what'd you get? You don't know how to do it. Danny, what'd you get? Are you Danny or are you David? David, what'd you get?
112.
112. Very good. It is 112. Let's see how to do this. Guys, do you recognize this is the definition of a derivative? So you agree, whatever your answer is, it's the derivative. Okay? But this is, remember guys, this is f prime of c. So you got to look at this problem and say, okay, where's my c in here? What's the c? It's the 8. Okay, so guys, this is really f prime of 8. All right? I'm good with that. So if I could just figure out what f prime of 8 is, that's this answer. Now, if you know the definition of a derivative, the alternate definition of a derivative, what you'll know is that this is the formula right here. And you need to know this anyway for your test. So let's just go ahead and write it. And if I ask you for the alternate definition of a derivative, you need to say that this is equal to the limit as x goes to c of f of x minus f of c over x minus c. Are you comfortable with that, guys? In first period, some of the students forgot this limit for the formula quiz, and they insisted that I should still give them partial credit. Okay, but I got to tell you, if you don't put this, okay, you actually didn't give me the slope of the tangent line. What did you give me? The slope of the secant line. You actually gave me something completely different. Okay, you gave me the slope of the secant line. I want the slope of the tangent line. So you need the limit there. All right, guys. So if this is true, what's my f of x? Cube root of x. How do I take the derivative of that? Rewrite. Okay, if I take the derivative of x to the 1/3, what's that derivative? Negative 2/3, right? Because if you're at 1/3 on the number line, you're going to move down to the left by 1. It'll be negative 2/3. All right, but guys, I don't really want f prime of x. What do I want? F prime of 8. All right, so if I get f prime of 8, this is going to be 1/3 times 8 raised to negative 2/3. Okay, that's really awkward. Okay, let's try this. What if I do 1/3 times 8 to the 2/3? Right? A little bit better, still a little awkward, but a little bit better. What is this answer right here? What is that? What if you cube root 8 and then you square it? 4, right? So this becomes 1/3 times the cube root of 8, but then you square it, which is actually the same thing. Again, guys, make sure you understand this is the same as 8 squared cube root. They're actually, you should go home, sit in a closet, see if this is the same. Okay, they're exactly the same. And so you should get 4 here, and your answer is 112. Okay, any questions on this problem? All right, you'll see it again, I promise. If
we put 1/3 times 8 to negative 2/3,
oh, that's a good point. Well, if it were a multiple choice, you definitely wouldn't have the answer. If it were a free response, it would just depend on how I'm feeling, and then also how I'm feeling about you. So, yeah, so I can't give you a definite on that. Okay, yeah, okay. So, but make sure you guys know how to do those. All right. I would say, you know what I would say, I would say I would expect you to know it. If it's easily done, if it's not easily done, yeah, you don't need to know it. Okay. Let's look at homework, guys. Let's go ahead and let me give you the solutions. I've already given you odd solutions, so I'm going to go through and give you some even solutions. Okay, so here's the answer to number 2, right here. So if you can pull out your homework. Here's the answer to number 2, right here. You guys have your homework out, right? Okay. Here's the answer number 2. Here's the answer to number 4. Right here, 21 cosine 3x. Okay. Here's the answer to number 6. Right here.
Did you do this problem?
Yes, I can. So here's the answer to number 6. Here, let me just do it right now. On number 6, you have to rewrite it. So this would be 7 times sine 3x raised to the 4th power. Okay. Once you rewrite it, it's easier to see the chain rule. I really like students to rewrite it. Some students like try to show off, and they should try to show that they can do it without rewriting. And I would say 50% of students can do it. Okay, not most people can't. So I know that's bad math when I say 50%. Whatever. I know that was bad math. But anyway. I would say, I would suggest you rewrite it. And so when you rewrite it, you can see chain rule happening here. This would be 28, leave the inside alone, and take the power down by 1, okay? And then when I take the chain rule, what that means is leave the inside alone, take the derivative of sine u. But remember, the derivative of sine u is cosine u du dx. And what is my u in this problem? 3x. Okay, so what I'm going to do is everywhere there's a u here, I'm going to replace it with 3x. So I'll just carry this answer here right up. So the derivative of sine 3x is multiplication. Cosine 3x times, what's the derivative of 3x? 3. Okay, and that's pretty much your answer, except I like you to have the 3 over multiplied by the 28. Okay, that's pretty much your answer. This cube, it doesn't matter if you leave it like this for the sign or if you bring in the 3. It doesn't matter. Okay, I actually like the 3 on the outside, but it's fine if you leave the 3 on the inside too. Okay, let's look at number 8, guys. Here's your answer at number 8 right here. Okay, I do like the negatives multiplied with any monomials that you have. So there's a 6x out there. So you want to multiply that together. Okay, number 10. I know where number 10 is. Here's number 10. Either one of those boxes is great for number 10. Okay. Number 12. Let's get another slide. Yeah, it depends on how you did number 12. So let me just give you some multiple answers here. If you did product rule, okay, you might have gotten something like this. It's possible that you did a different product rule. Oh, I just realized I erased all my answers for number 12. Okay, well, there were some other answers. Oops. There are some other answers for number 12. Did anybody get like a secant answer for number 12? Cosecant answer? You didn't. Okay, then you didn't do the other part rule, because you could actually change this to cosecant x. So it'd be x times cosecant x and done product rule there too. So that would have been another thing. Or you could have simplified this out. And oh, here, yeah, there's a cosecant answer, I think. Actually, I'm not sure. But you could have actually like multiplied this out, got a common denominator, seen that this was actually cosine sine x minus x cosine x. I don't know if this is helpful, but this is possibly another answer. Did anybody get a different answer? I'm not sure. There are multiple ways of doing this one. Okay. All right. Does anyone want to see this one?
Sure.
You do want? Okay. So let's look at this one. Okay, you guys can stop me about where you want to see it. But did you want to do product rule or quotient rule? How did you guys do it? Quotient rule. Okay. So if you do quotient, it's going to be the derivative of the first times the second minus, right, the derivative of the second times the first all over sine squared x. If you did that, then this is what you got down here. I'm just going to try to rewrite it. You should have gotten, oh wait, you should have gotten this answer right here. So it's the same as when I did, what is it, when I did product rule. Okay. All right. Yeah, if you, yes. So number 10, I rewrote it. Did you do quotient rule or did you rewrite it as product rule? You rewrote it as product rule? Okay. So if you rewrite it as product rule, you should have gotten something that looked like this to the negative 1/2. Okay. And then I would say, okay, well, there's your outer layer right there. Here's my outer layer. So that would be negative 1/2 times 5/3, which is negative 5/6, 2x plus 1. And if I was at negative 1/2 on the number line, I moved down by negative 1/2. Now I'm at negative 3/2. And I think that's pretty much my answer. Can someone check me on that? Because I think I erased everything. Oh, that's what I forgot. Oh, thank you. Who said that? That's wonderful. Thank you, Miriam. I did what you're not allowed to do. When I took the power down by 1, I also need to do the chain rule. So I need to multiply by the derivative, which is 2. And so if you, let's see, so if you move that down by 2, the 2 cancels out with the 6 here. So this becomes negative 5/3, 2x plus 1 raised to negative 3/2. And that's what you should get. Thank you. All right, what other questions are you good on, or you needed help on, 10 to 12? You good? Okay, let's move to 14. So 14, the answer is just 8. Hopefully you got that. 16, I don't know where 16 is. It must have been on this other slide here. Okay, 16, the answer is negative 8 cosecant 2x quantity squared. Okay, that's 16. Okay, and then 18, guys. Here's the answer for 18. Right here, you can check your work. Good with that? Okay, and then 20, your answer was just 0. Did you guys get 0?
Yeah.
if you look at your work, the left side and the right side are both the same. Look at it, 0. Do you see it? The left and the right side are both the same. Does anybody want me to do it?
Absolutely.
Okay, so this would be 4 sine, you have to rewrite it, right? So this would be raised to the squared, okay? On the right side, this would be rewritten and raised to the squared also. You guys good with that?
Yeah.
So then when you take the derivative here, this would be 8 sine x minus 3. Okay, take the power down by 1, but you also need to take the derivative of the inside. So that's cosine x minus 3 times 1. Right? Let me write this to make sure you understand. This is the derivative of sine u, which is cosine u times du dx. But what's my u in this situation? So you see it's x minus 3. Well, that'd be x cosine x minus 3 times the derivative of x minus 3. What's the derivative of x minus 3? 1. You see that? Okay, plus, Miriam? What'd you say? Yes, you can. Okay. And then right over here, I thought you were saying something else. Okay. I wonder if I could just move this. Yeah. Okay. On this side, what you get is the outside here is 4 squared. So this is actually 8. Leave the inside alone. Take the power down by 1. What's the inside of this one, though? Cosine x minus 3 times the derivative of cosine u. But the derivative of cosine u is equal to negative sine u times du dx, right? But what's the u in this problem? X minus 3, right? So x minus 3. Okay, x minus 3. That's okay. If you don't tell me, I'll tell you. Okay, so the derivative of this, let me just carry down this side. It's going to be negative sine quantity x minus 3 times 1, right? Because the derivative of x minus 3 is just 1. Okay, so then this is basically your answer, but if you look carefully at both of them, this is a positive 8 and that's a negative 8. They have the same, they're going to have the same, what do you call it, like terms or whatever, variables, and so it just becomes 0. Okay, all right, that's 20. Let's look at 22. This is what I'm getting for 22 right here. Close? Okay. Then 24, guys. 24, you can get either box. Actually, you probably stopped at the red box, so it's probably the red box. Oh, it's a red box. Oh, okay. And 26. 26, you probably stopped here at the purple box.
Oh, yeah.
Is that right? Okay. You could have moved down and factored, but you probably stopped there. And then let's look at 28. 28 is this answer right here. You guys good?
No, I didn't get it right. That one. Oh, I distributed the x to the second parenthesis.
You can do that if you want. It's just more work. Yeah, that's fine. Okay. And then 30, guys. I would put a star by this. Students have problems with this on the test. So just FYI, make sure you understand that don't do anything to this 5. Like, leave the 2/5 alone. Only the x to the 6 is really what you need to rewrite. Okay, students do crazy things to the 5 and they get crazy answers. All right, so number 30, either one of these boxed answers is great. Okay, that's number 30. And then finally, guys, number 32. Here's your answer for 32. Okay, so guys, I think for time's sake, I'll probably check your quiz, check your homework while you guys are taking your quiz. Okay, so there's 32. All right, your homework, guys, for tonight is going to be to finish up the rest of this worksheet. I want to go over something on your homework, though, first before we get moving to the formula quiz, and that is if you look at the very last sheet of your homework, the last problems in your homework, you'll see like a table, and they expect you to use the table to figure out some derivatives, okay? So I want to show you how to do that, and I think you do. You've already, on the homework, if you did My Math Lab, okay, on one of those homeworks you used a graph to figure out the derivatives, and this is basically the same thing, but they can throw in some curves, okay? Charles, you're good? Okay, so guys, right here, if they, are you guys missing something on there? Okay. Oh, got it. Okay, so right here, guys, if they ask you for h prime, and they tell you h is equal to this kind of weird function Can you tell me what rule they're trying to get you to use? Not the product rule, chain rule. Is everybody good with that? Okay, so guys, this is the chain rule here because this is a composite function. So what they're trying to get you to do is to say that you know that h, if this is h, the h prime is equal to f prime, leave the inside alone, multiplied by the derivative of the inside. You guys good with that? So guys, you might see this on a formula quiz, okay? This is the chain rule, all right? Okay, so guys, if this is true, see if this makes sense. All you want to do, if they're asking you for h prime of 3, is everywhere there's an x, what do you put in? A 3. So what you do is, once you write the chain rule, then everywhere there's an x, you just put in a 3, okay? And then you go to your table. Here that I just give you the numbers, but you go to a table and you find these numbers off a table. And sometimes you have to find it from a table, and sometimes you have to find it from a graph, okay? So on your test, it could be a table, it could be a graph, or it could be both. But you have to find these little numbers from the table or the graph. So for example, if I want to go find g of 3, what's g of 3 on this problem? You guys see it? What's g of 3?
2.
It's 2. So what I would do is I would replace g of 3 with 2. But once I replace this with 2, you see now I have another problem. What's f prime of 2? So guys, look at your table or look at what you're given. What's f prime of 2? 1. So then what happens is this number here becomes 1. Okay? Then what's g prime of 3? Negative 5. So do you see my answer here would be 1 times negative 5, which is negative 5. Does that make sense? Okay, so this is if they're testing you on the chain rule. Of course, they could also test you on what rule would this be, do you think you're trying to get here? The product rule. Does that make sense? If you're doing this problem on a formula quiz, which you could be, I don't know, in a few minutes, okay? So this would be, see if this makes sense. It would be the derivative of f times g is the derivative of the first times the second plus the derivative of the second times the first, right? Okay, this is great for the formula quiz, but I got to tell you, if I want to plug in 2 everywhere there's an x, now I run into a problem because there's no x here, okay? So what I want to let you know is sometimes you gotta rewrite it with the x's in it. Does that make sense? Okay. Now again, while the top one is correct, while this one is correct, this one helps you do the problem. This one helps you with your problems. Okay. Your shrink will also help you, but not all of you can afford a shrink yet. So right now you just need this formula. Okay. And what this formula says that anytime you have an x, put in a 2. And so I would put in a 2 here, a 2 here, a 2 here, a 2 here, and a 2 here. And can you comfort me and assure me that you can use this table to look up each of these values? Does that make sense? And plug in. You guys good with that? Okay. So for example, if I wanted f prime of 2, what would the answer be? F prime of 2. 3. Does that make sense? So this would be 3 times g of 2. So g of 2 would be 1 plus something times something. Is everybody good with that? So I'll leave this answer, the real answer, online, but I wanted to just work it through partly with you guys. Okay. Now I got to tell you, it can get way more fun than this. Okay. What rule are they trying to test you here? Quotient rule. Okay. And so again, guys, if you took the derivative of this, you need to understand that that's the derivative of the first times the second minus the derivative of the second times the first all over the bottom squared. Very good. Okay? And guys, I'm not trying to find a prime of x, though. I'm trying to find what? A prime of 6. So you would come back, and everywhere there's an x, or if there's not an x, put those x's in. And then can you tell me that you know how to use a table to plug into this problem? Very good. Okay, so let me show you something way more fun than that. Okay, this is kind of what you'll see on an AP test. A lot of times you'll see something easy like what we've done, but a lot of times they could give you something like this. Okay, they could say, use the table to find the derivative of this at 2. Can you take the derivative of this? What rule are they trying to get you to use? Chain rule. Okay, so let me talk you through this, okay? Do you agree that this is the outside of this problem? Okay, so if I took the derivative, it would be 5 times 1. Do you agree with that? Leave the inside alone. Take the power down by 1, right? What is the inside here? Do you agree with that? Okay, now here's the trick. Do you agree it's a chain rule, right? So I need to take the derivative of that. Okay, yes, you think it's 2x, but let's look at this. It's a chain rule within a chain rule, right? So what's the derivative of f of gx? Isn't that equal to the outside, right? Leave the inside alone, right? Leave the inside alone. Then take the derivative of the inside and multiply them together, right? What's the inside of this problem? X squared, okay? So what this is, I'm sorry, it's the derivative of the outside. Do you guys see that? Leave the inside alone. What's the inside again, guys? Then take the derivative of the inside, which is 2x. So it's a chain rule inside a chain rule. Do you guys see that? Multiple chains, okay? And then here's the trick to this problem. Everywhere there's an x, what am I going to put in?
2.
A 2. Well, guys, if I put in a 2, what's this become?
4.
4. What's that one become over there? 2 times 2? 4. So this becomes 5 times f at 4, quantity, wait, is this the fourth power? Yeah, raised to the fourth, f prime of 4 times 4. Does that make sense? And from here you would plug in and use the table. Okay? Now was that fun? Okay? Make sure you can do this for the test. Okay. And that's pretty much what I wanted to cover with you guys. You have time for a formula quiz now. I'd like you to leave your homework out so I can check it, please. And take out a blank piece of paper. Okay, you have 10 questions for the formula quiz. Okay? I'd like to review you really quickly. Are you guys okay with that?
Yes.
Okay. So guys, what's the derivative of sine u? What's the derivative of cosine u? What about tangent u? Secant squared. Okay. What about cotangent? Negative cosecant squared. Okay. Don't forget the u though. U, du, dx. All right. What's the derivative of secant u? Secant u, tangent u, du, dx. What's the derivative of cosecant then? Negative cosecant u, cotangent u, du, dx. What's the derivative of this chain rule thing right here? That f prime, leave the inside alone. G of x, C prime of x. Okay, guys, what if I asked you about IBT? Do you remember IBT? Okay, IBT says that if you have a function and the function must be something, okay, between on the interval of a, b, then f attains every value between something and something else. Can you fill in those blanks for me?
Oh, absolutely.
Okay, IBT says, remember, if I have a function, okay, and that function is something between a and b. Do you remember what that word was? What's this word? Continuous. That function must be continuous. If it's not continuous, then this rule does not apply. Then f is going to hit every value between what two values? F of a and f of b. So I want to let you know, a lot of students say that f hits every value between a and b. That's not true. F is a y value. Does that make sense? So y's hit every value between f of a and f of b, not between a and b. All right, guys, let's go ahead and get started. Write your name at the top of your paper, and here's your quiz. There's also a bonus, so do your bonus at the bottom. And I'm going to go around and check your homework.